Good afternoon, everyone. My name is Gajtkowski, and I work as a data scientist within the Financial Times. Today's talk will focus on introducing our recommender system, which is called NBA. NBA stands for Next Best Action. This recommender system has been developed in order to improve experience of our users and potentially increase their engagement both with our website and our application. Today's talk will go through the following times. So first of all, I will explain why does the fee need recommender system, what is actually our recommender system, and I will explain in detail the two main components of our recommender system, which is the action values and a likelihoods component. In the end, I will briefly mention the history of our recommender system and I will analyze its performance. Some of you may wonder, why does a newspaper, Financial Times, why do we need recommender system? And actually, Financial Times is mainly the subscription business. 80% of our customers are digital, whereas only less than 20% are actual newspaper readers. And that gives us a lot of data to work with. And we have a data science team who work on a project such as predicting which of our users will become disengaged, or we try to predict the preferences of our users, and obviously we also design recommender systems. The NBA in particular aims to increase user engagement, and our engagement metrics is called RFV, which stands for recency, frequency, and volume. So if at any point I say RFV, just don't be confused, it's simply an engagement metrics. And then the NBA has been developed as a product, as a consequence of cooperation of both data science team and Envoy team, which is responsible for direct contact with our customers. So they basically take output of our recommender system and they deliver it to our customers. Let's move on to the workflow of our recommender system. So our recommender system consists of two main parts. These are the static elements located in Google Cloud Storage, and then we have a dynamic daily model run. The static elements consist of both likelihood models, training, and action values. The likelihood models predict the probability that a given user will take some action in the future, and the action values indicate the expected increase in engagement from taking given action. The model run fetch both of those components and also also gathers the most recent behavioral data from our customers. Then it puts it together and produces some outputs, and those outputs are ranking of next best actions. Then those outputs are displayed, those outputs are loaded to the big query, and from there we automatically analyze those outputs by the interactive dashboard and notification bots. So let's see what this recommender system actually does. On the left-hand side, you have 7 actions which we have selected. These are, for instance, signing up for the newsletter or using our Financial Times application. And for each of those actions, we predict the action relative value. And what action relative value is the output from this equation in the middle. So for each user, we predict the action relative value for each of those actions. And the action relative value is computed by summarizing the action likelihood multiplied by its weight with the action value multiplied by its weight. So as I mentioned, what action likelihood is, it is the probability that a user will take a given action. So for instance, what is the probability that a user will sign up for the newsletter? We give some inputs to our model, then this model outputs probability, and we multiply it by 1.5. And then we summarize it with the action value, which indicates what is the expected increase in engagement of our user from signing up to the newsletter. And then we multiply it by its weight, which is 0.5. We sum those two things together, and as I said, it is called the action. We come up with the action relative value. So we compute the action relative value for each of those actions, and then it creates the ranking of top actions. So the higher action relative value, the better. Then we come up with this ranking, and this ranking then goes through the resuggestion filter. And what resuggestion filter means is that, for instance, if the user signed up for the newsletter in the past 3 months, or if the user has used application in the past 3 months, then even if this action is the top action as suggested by the action relative value, then the resuggestion filter will filter it out and then would select the second or third best action. So that's the basic logic behind the next best action recommender system. Some of you may wonder why we have chosen those specific weights. So based on our research, both from correlation analysis and from the principal component analysis, we discovered that actually the likelihood model is way more important than the action value. So this presents the kind of summary of the principal component analysis, which we conducted. The XYZ axis represents principal components, which are weighted averages of some subsets of all investigated actions. The yellow dots represent the readers who are disengaged with our website, and the blue triangles represent the engaged readers. So you can see that the disengaged users tend to cluster in the middle, which means that basically they didn't take any actions at all, versus the engaged readers are spread all over 3 principal components, which means that the way we interpret is that it doesn't matter which action user takes. What matters is that the user takes this action. So that's why we assume that the probability of a user taking given action is way more important than expected increase in engagement of this user. Then these are the inputs of our model. So the inputs to both our likelihood model and in order to compute the action values are actions and the most recent engagement metrics. So the way we define action, we look at behavior of the users in the past 3 months, and then if the user performed given action, then we flag this action as true, and if the user didn't perform this action, we then flag it as false, and then we pass it to our action likelihood model and action value model. And for action likelihood model, we also gather the most recent daily engagement matrix, which is the most recent daily RFV. These are all the actions which we have researched initially, and then based on the domain knowledge expertise of the Envoy team and based on the correlation analysis and principal component analysis, we come up with those 7 top actions, which are then used in our model. We also conducted correlation analysis just to eliminate some actions which seemed not to be highly correlated with the engagement. So for instance, here you can see that searching content, fast FT, or market sections are the actions which are most highly correlated with the engagement matrix RV. Then we also check the cross-correlation in order to eliminate any actions which are possibly related to each other, and then we put those actions together. And this, for example, is the action value ranking. Here is obviously more than 7 actions. And what action values are, these are actually the standardized coefficients from the logistic regression, where our dependent variable is engagement flag. So we check whether user is engaged or disengaged, and then we try to explain it with all those actions. And we standardized those coefficients because otherwise this equation could be dominated by some action values, and we want it to be standardized just to give more or less equal weight to those components. And we want to manipulate with this manually, this weight. And then for the higher standardized coefficient, the higher possible relation of the given action to the engagement. So for instance, here we can see that newsletter, fast FT are most highly correlated with the engagement versus the following columnists, or using markets portfolio section has a negative impact on the engagement. And here is example of our likelihood model. So we have trained 7 likelihood models. Each likelihood model relates to each action. And the likelihood models are based on the graded boosted machines. algorithm, which is basically an assemble of decision tree with a different loss function. And we feed all the action to this gradient boosted machines and the most recent RFV. And obviously, we exclude the action of interest from our features because that's our outcome variable. And then after training those seven gradient boosted machines models, we just input most recent features of a user and come up with the probability of user taking given action. Here's a brief history of our recommender system. So initially, we assumed that the equal importance of both likelihood and action values components. And so we just multiplied the action value by the probability of a user taking given action. But right now, we have changed this formula just to have more control over outputs of the model. And we have also static action value ranking, so we couldn't update the action value ranking. We just computed it once, and then it just stayed as it is. And we investigated the limited amount of actions. Then during next iteration, we removed some actions, and we added resuggestion filter. And finally, for the newest version, we have added adjustable importance of model components. We have changed the formula. We have added the dynamic action value ranking, and we have investigated new actions. Here is the result of how effective our recommender system is. And it was an A/B test, which we conducted based on, we just checked the first version versus the random assignment of an action. And we have seen great results. These are the statistically significant results. So we saw the 63% increase in newsletter signups. We have seen around 4% points increase in newsletter promo views and in app promo views. And we also see the increase in click-through ratio of newsletter promo by 4.4% points. However, some of our actions, such as personalized my FT messages, had negative uplift. Most recently, we also conducted the A/B test of the NBA v1.1 versus NBA v2 version. So this graph shows the median RFV, so this median engagement on the y-axis, and then on the x-axis we have a day number of a given A/B test. So we can see that the median RFV is quite close in both V1 and V2. So we didn't see any positive impact of changing the formula or investigating new actions. But obviously, it doesn't mean that this model is worse. It means that it's equally as good as the first version. Here's an example of the outputs of the model. So these are the counts of users which have been assigned to a given action. So for instance, here we have signing up for a newsletter or signing up for app. And then you can see that those actions has been the most popular within our users, and mostly infrequent and regular readers has been assigned to those two actions, whereas the super readers has been assigned to fastFT or gift links action. And this is basically a consequence of resuggestion filter, because probably those are super readers of FT already sign up for newsletter or are already using application. That's why we just suggest actions with the next action with top action relative value. In order to make sure that the performance of our model is good, we monitor it on a daily basis. So we monitor it both by Shiny dashboards, and both us and our stakeholders have access to those Shiny dashboards. So for instance, here we have the root mean squared error of our gradient boosted machines model. And this is also an example of output of our model. So we also display some summary statistics just to make sure that outputs are as expected. And we also set up a Slack notification bot, which checks whether the job ran within the last 24 hours or whether some statistics, such as the number of missing values of our model, is within the expected range. So if there's something wrong, or if the model didn't run within 24 hours, then we get both email notification and Slack notification that there's something wrong, and then one of our team members goes and investigates this issue. So just to sum up this talk, the NBA Next Best Action Recommender System intends to improve the experience of our users. And the NBA system consists of two main components, which are action, values, and likelihood models. We put those components together and we come up with the ranking of best actions subject to resuggestion filter. The future possible iteration includes possibly extending the gradient boosted machines with more features just to get predictions, or just to get higher accuracy of our probability predictions, and possibly breaking down the action values rankings by different cohorts of users so that the output is even more personalized. We are also hiring both for data science and senior data scientist positions. So if you are interested, simply go to our website and go to the careers subsection of our website, or alternatively, you can just copy paste this link. Thank you for your attention. Do you have any questions?
We have time for a couple of questions, and we've got our roving mic. So does anybody else?
Hi, thanks so much for the presentation, really illuminating. My expectation from a recommendation system from a newspaper would be, given a newspaper article topic, what would be the topic that you would recommend the person? And typically, if it was about company A, other articles on company A would be relevant. And you talk about something quite different. My question is, and that was actually kind of, I didn't realize that was actually also a much more business-oriented but a relevant thing for the FT. If you had to build a model that was a bit towards the topic of the article or something like that, would you integrate it as an improvement of that model with more dimensions, or would you make it as a second step model? How would you organize topic with the actions?
So we could include, we could analyze which topics could be the most relevant for our customers, and then we could include it as a part of newsletter action. So for instance, given that user had read some articles in the past, we could suggest the similar articles and embed it within the newsletter app. So it would rather be like a separate model. However, it would be somehow embedded within the next best action system.
Makes sense. Thanks so much.
Just behind you.
Hi, thank you for the presentation. I am just about the months.
Would you speak up, please?
Yeah. Use 3 months of data.
Yes.
Is there any explanation for that? Because the actions could be quite cyclical in, I don't know, like elections period. Some users may have some type of actions, and in another period, those users might have different actions. So is there any explanation for just the 3 months of data? Did it try to use more data or not?
Well, we didn't try to use more data because we want to keep our user engaged. So for instance, if we took longer period of time, then possibly this could mean that user was engaged like 6 or 9 months ago, and then we wouldn't suggest this action to our user. So let's say the user, for instance, stopped using application most recently, so within the past 3 months, but he used application once, like 6 months ago. And then I guess, in our opinion, it wouldn't be really desirable to not suggest the app action to this user because he stopped using that, and then using application is actually highly related to the engagement and experience of our users. So I guess, yeah, the answer for this question is that we just look at the most recent data, the data within the past 3 months, because users can become suddenly disengaged with our website or with our application, and then we want just to keep them as engaged as possible.
Thanks.
So obviously, for training our data, we use way more. We use way wider horizon, but it is just as for inputs.
Thanks.
Hi, thanks for your presentation. What do you do about measuring the effectiveness of the system around business metrics? So against, like a control or not doing any kind of recommendations at all, or random recommendations or something like that?
Could you rephrase this question?
Well, so obviously on a daily basis, you have a metric that measures the model error loss in RMSE, but I'm thinking if your recommendations were poor or they were good, how would you know the difference?
It is this metric. So it is RFV, which stands for recency frequency volume. So it is like equation based on those three variables, which is a measure of, it is actually a business metrics within the FT, which measures the engagement of our users. So when we look at how effective this model is, we mainly look at the impact of it on RFV, for instance, against the random assignment. So for now, this is our main business metrics.
Okay, thank you.
Are there any other questions? If not, then I have one. That's okay.
Yeah.
Oh, you have a question, right? Go for it.
So your model is basically based on this customer engagement metric, and I was wondering if this customer engagement is somehow related to customer churn that you've analyzed separately, or is it completely independent?
Could you repeat the last part?
Yeah, so my ask is like, because obviously you are trying to build recommenders just to keep customer engaged, and obviously you are a subscription model, so basically what you want to have is as many users as in your subscription. Yes. So my question is like, have you analyzed any customer churn and included any of that information in your customer engagement metrics, or are these completely independent?
Well, I mean, this customer engagement metrics is, well, the only inputs for now of our model is we just track those actions and the most recent engagement metrics. So no, for now, these are the only inputs to our model.
Okay, thank you very much.
Okay, thank you very much, Adam. Let's thank Adam once more.